Good morning, audience, and welcome to today's class. Today we have come again to discuss some problems in mathematics relating to the concept of indices. Indices is one among the topics in mathematics that is often presumed by students to be very elementary and requires little effort. However, the concept happens to be the foundation of so many mathematics problems. So, standing on our promise to make sure that we provide you with the foundation of so many mathematics topics, we have come this morning to solve some questions drawn from indices with the intention of using the questions to revisit the ideas or the laws of indices that will go a long way to assisting you tackle other mathematics problems, even outside the indices. So without wasting much of your problems, let us call up the questions on the board and solve with you. At the end of which I know for sure that you are not going to regret being our audience this morning. Permit me to remove what came up on my screen. So let me call up the question. Question number one says, and I write, question number one. Question number one says, it says, if x raised to power 1 over p is the same thing as y raised to power 1 over what? Over q, which is the same thing as what? Z raised to power 1 over what? Over r. And x, y, z equals what? 1. Then the value of P plus Q plus R is what? And they provided us with the option. Option number A or option A says 0. Option B says 1. Option C says what? 2. And option D says a rational number. A rational number. A rational number. Permit me to write NO as what? As a number. That is just the question. We are told that three quantities are the same thing. And these quantities appear in the form of what? Of indices with powers. However, here the base is a letter, the power is equal to letter. So we have to be careful as we go about this. They say x raised to power 1 over p is the same thing as y raised to power 1 over q, which is the same thing as z raised to power 1 over r. Okay? And then we are given an additional information that this x, y, z is equals to what? 1. So what becomes the value when these letters p, q, and r are added up together? Option A says that when they are added up together, we get 0. Option B say we get 1. Option C say we get what? 2. And option D say we get what? A rational number. So let us now solve together to see what becomes the value of a P plus Q plus R. So stay tuned. Let me divide this here. Are we there? So as a way of solution, we come here. We don't know what this is, we don't know what this is, we don't know what this is. So we can say, let them be something. So I can say, let x raised to power 1 over what? P equals y raised to power 1 over q equals what? Z raised to power 1 over r be what? Be k. Because I don't know what their values are. And if you say let all this be k, it implies that I have said that let this be K, let this be K, and let this be K, because they are all equal to each other. So you now say therefore, my x raised to power 1 over what? P equals what? Equals K. Okay? And for you to make this x to stand all alone, because the interest here is I want to make x stand alone, I want to make y stand alone, I want to make z stand alone. So if I want to make x to stand alone here, I am now going to multiply both sides with what? Power of what? Of p. Power of p means that I'm going to come here and say this is raised to power what? P. This is raised to power what? P. And on that note, this p will cancel this p. So that this thing implies that my x is equals to what? K raised to power what? P. That is what it is here now. By using the power of p to multiply both sides. So that this p can cancel this p. Here is k raised to power 2 p. This x is now standing alone. X equals k raised to power what? P. Then I will now come here now. I have that y is raised to power 1 over what? Q. This equally is equals to what? K. For me to make this y to stand all alone, of course, I'm going to use q as a power to multiply both sides. So I have open this way and close raised to power q, open and close raised to power what? Q. In that case now, this q will cancel this q, and then this thing implies that I have that y is given as what? K raised to power what? Q. The same thing applies with this z. So I have that this is z raised to power 1 over what? R, which is equals to what? K. I want to make z to stand all alone. I'm going to use the power of r to multiply both sides. So I will do this and do this, raised to power r. I will equally do this and do this and raised to power what? R. By so doing, this r will cancel this r. And of course, z raised to power 1 is z, y raised to power 1 is 1, is y, x raised to power what? 1 is what? Is x. That was why we had x here, had y here. So here, it is going to imply that my z is given as k raised to power what? R. So we have now come to realize what are the values of the letters x, y, and z in terms of what? Of k, which is what we said let it what? Be. At this point in time, we recall that they gave us an additional information that x, y, z is given as what? As y, as 1. In fact, it is because of this x, y, z that we had to make effort to find the true values of this x and y, z, to make them to stand all alone. So I will now say, recall that. I will say, recall that x, y, z equals what? 1. But our x is this. So in place of x, I'm going to write k raised to power p. So I have k raised to power p in place of this x multiplied by, y. In place of y, k raised to power p. So I have what? K raised to power what? Q multiplied by. In place of this z, I am going to write what? K raised to power r. So I have k raised to power what? R. This is given as what? As 1. Of course, we know quite alright that if you watch in indices, once the bases are the same thing, we take one of the base and then add up the powers if the signs in between them are multiplication signs. So what I'm going to do is to pick one of these k's and then sum up what the powers. And by doing so, what I'm going to have here becomes what? K. Here is my P plus. Here is my Q plus. Here is my what? R. This is equals to what? 1. Now, if you find out here, the number we have at the left-hand side is in form of what? Of what we call index number. That it contains a base and contains what? A power. So it is good that we express what we have at the right-hand side in form of what? An index number equally, or a number that contains what? A power and a base. And of course, in doing so, in as much as what I have here is what k, I am going to express it now in form of what? In form of k equally. You know in mathematics that anything raised to power 0 is 1. 1 raised to power 0, 1. 2 raised to power 0, 1. In fact, anything at all raised to power 0 is what? 1. And what I have here is what? 1. So I'm free to replace this 1 with what? K raised to power what? 0. So in that case, what I'm going to have here becomes what? K raised to power P plus Q plus R is given as, we have K raised to power 0. In as much as this K raised to power 0 is the same thing as this. If you watch, what I have here is K and what I have here is K. In indices equally, whenever the bases are the same at the left-hand side and right-hand side of the equation, they can be cancelled off now and then their powers equated. And in doing so, I will now cancel this K and cancel this K. Then I will bring this in down, that therefore my P plus what? Q plus R is equals what? 0. So that becomes what? The option A. That P plus Q plus R is what? That's the question they asked us. So if you are not familiar with these, fundamental operations surrounding indices problems, you may not be able to quickly come up during exam that the value of this plus this plus this is given as what? As A. So I do believe that, of course, a problem like this coming before you again will be able to thrash with ease. That is how to go about this. Do not forget to subscribe to our YouTube channel so that each time we have a class, you will definitely get it. Subscribe to the YouTube channel, turn on the notification bell so that you get an alert, or you get what we call a notification once we upload a class. Permit me to clean this while we call up another question and still solve with you. Thank you very much. That question which we want to solve with you says, and I write, it says, number 2, it says find the value of x if 2 raised to power 3 multiplied by 3 raised to power 4 multiplied by 1008 divided by 15 is given as 6 raised to power x. We are to find the value of x if this 6 raised to power x is equal to this quantity. This is a serious question in indices. But before we tackle this problem in indices, definitely we are going to recall a very important acronym in mathematics called BODMAS, which is a rule that guides expressions in mathematics, evaluation of expressions in mathematics involving brackets, involving off, involving division, involving multiplication, and involving subtraction. So as a way of solution, permit me to divide this board. So as a way of solution, I'll write BODMAS. 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 Then let us now come back here. I have multiplication here. In fact, I have bracket here. There's no bracket here. I have off here. There's no off here. I have division here. So division comes first here. And look at where I have division. This is the place where I have division. So I can call up that division first. So this thing can be written as what? 2 raised to power 3 multiplied by 3 raised to power what? 4 multiplied by 1080 all over what? 15 equals 6 raised to power what? X. I have treated the issue of division. And if you check, when 15 goes into 1080, it is 72. So if you say 15 itself is what? Is 1, into this is 70 what? 2. So that what you have becomes what? 2 raised to power 3 multiplied by 3 raised to power 4 multiplied by what? 70 what? 2 is given as 6 raised to power what? X. Now, there's something I want to say that is very significant. What they gave us here is 6 raised to power X. And there is no way we can express this what? This 6 again in form of what? An index number. A single index number that contains a base and contains a power. You cannot. The highest you can talk about what 6 is 2 times what 3. Okay? So what we are going to do is to make effort and express everything at the left hand side to appear as an index what? Number with the base of what? Of 6. It is only that condition that can make us cancel and bring X down. So first of all, for that reason, I'll come to 72. I'll say 72 equals what? Let us see what 72 is. If I do a line like this, and I write 72 here, the smallest number that can go into 72 apart from 1 is what? Is 2. 72 divided by 2 should give me 6. Okay? Then if you watch now, this 36 now, which means 2 times 36 is now is 72. So I can come here comfortably and say 2 raised to power 3 multiplied by 3 raised to power 4 multiplied by, in place of this 72, what I have becomes 2 times what? 30 what? 6. This is equals to what? 6 raised to power what? X. You don't know very much where that 36 is 6 raised to power 2. Okay? And this 2 is just like 2 raised to power 1. So what I have here becomes what? 2 raised to power 3 multiplied by 3 raised to power what? 4 multiplied by 2 raised to power 1 multiplied by 6 raised to power what? 2 is given as what? 6 raised to power what? X. Okay? Now if you watch now, there is 2 here, there is 2 here. The bases are the same thing, so I can pick one of the bases and add the powers. So in that case, what I'm going to have here becomes what? 2 raised to power 3 plus 1 for this one. I am done with these 2. Then I'll now come with this 3. Then I'll say multiply by what? 3 raised to power what? 4. Multiply by 6 raised to power what? 2 is given as 6 raised to power what? X. Now, what is the power here? 3 and 1. 3 plus 1 is what? Is 4. So what I have here becomes what? 2 raised to power 4 multiplied by 3 raised to power what? 4 multiplied by 6 raised to power 2 equals 6 raised to power X. That's what I now have here. At that point in time, what is the power here for? What's the power here for? Whenever the powers are the same thing for 2 numbers, we can take the product of those numbers and raise it to the power of what? 4. So if you have something like 2 here raised to power 4 times 3 raised to power 4, the power here is 4, the power here is 4. They are the same thing. So you can equally come and say that this thing is the same thing as what? 2 times what? 3, all raised to power what? 4. Because if you want to come back here, these 2 shares in this 3 shares in this. And you can quickly say 2 raised to power 4 is here, your sign is multiplication, 3 raised to power 4 is here, then you are back here. So this and this are perfectly the same thing. So we progress. Then we now say multiply by 6 raised to power 2. This is given as what? 6 raised to power what? X. At this point in time, here is 2 times what? 3, which will give me 6. So I now have what? That this is 6 raised to power what? 4 multiplied by what? 6 raised to power what? 2 is given as 6 raised to power what? X. If you watch now, we have established every effort now, such that what I have at the left hand side appears in what? In base 6, and what I have at the right hand side is already in base 6 given to me. So I can say, okay, fine, here is my 6 and here is my 6. I still pick 1. So what I have becomes what? 6. The power here is what? 4 plus what I have here is what? 2. This is equal to 6 raised to the power what? X. At this point in time, I now say 4 plus 1 is going to give me what? 6. So I have what? 6 raised to power what? 6 is given at what? 6 raised to power what? X. Now I have 6 here, I have 6 here. They can be cancelled off. And the moment they are cancelled off now, we now equate their what? Their powers. So this and this is gone. And we say therefore our x is equal to what? 6. So it is only when x takes a value of what? Of 6 that this equation can be what? Can be satisfied. This is a problem in indices, which of course, if you are acquainted with some of these things we are mentioning about what indices, definitely will go a long way solving such problems. We want to come back to the basis, go to the archive of problems that connect these basics, remove them and then solve with you, so that at the end, your foundation in mathematics will be that of a strong one. So this is how to go about this. Thank you for making our audience this morning, and do not forget to subscribe to our YouTube channel. We are committed to make a transformational change in you that at the end you are going to appreciate. Stay tuned for our next class.